Hey guys, Marina here with another algebra video. This is going to be for Wednesday, March 25th. This lesson is called Factoring Completely. So we've already learned three methods of factoring. The first one from last Friday, called Greatest Common Factor, or GCF. The second way, difference of two perfect squares, or dots. And then the third way, from Tuesday, factoring trinomials, or the AM method. So in this do now, we'll see that I have one of each. So we'll see here the first one, x squared plus 6x plus 40. Let's go through the three methods. You always want to start looking for greatest common factor because that's the first one that I taught you. And I noticed that x squared, 6x, and 40 don't have any like terms. They don't have anything in common, so it's not going to be the greatest common factor. It's not the difference of two perfect squares. First of all, it's a trinomial. And second of all, besides x squared, I don't see any perfect squares in any of that. So it's a trinomial, and we're going to use the AM method. So I'm going to rewrite the problem. And for AM, we go like this. Two parentheses. First term is x squared, so x times x. And now we get to think of numbers that multiply to negative 40 and add up to positive 6, which would be positive 10 and negative 4. If you feel like writing the answer like this, you can. 9y squared minus 1, that's the difference of two perfect squares. What times what gives you 9y squared? That would be 3y times 3y. And what times what is 1? That would be 1 times 1. And remember the rule for dots is 1 gets plus and 1 gets minus. And the last one. At first glance, you might say to yourself, that's a trinomial, so let's do the AM method. However, I do notice that they all have something in common, the number 2. And the greatest common factor is 2, so we divide all of them by 2. And that leaves us with and that goes in parentheses, and you put the GCF in front. Now, if we were in school right now, I'd say, where have you seen this before? And after maybe 30 seconds of staring at it, you might realize that that's the same as the first question. The reason why this lesson is called Factoring Completely is because sometimes when you factor, you're not finished. We can take this parentheses and factor it again. And we saw for number 1, this was AM, x plus 10, x minus 4, and bring down the 2. And that's called factoring completely. Very common question. Mr. Marini, do I have to do that? Yeah. Okay. If you can factor something again, keep factoring it until you can't go anymore. So that's what this lesson is going to be about. I will do 3 examples with you, and then I'll leave you guys to do those, and you can check the answer key and ask me questions in the Google Hangout. All right, here we go. 4x squared minus 24x minus 28. First step, look for a GCF. I do see they have something in common. All right. If you didn't figure it out by now, they all have 4 in common. So divide everything by 4. And that leaves us with x squared minus 6x minus 7. Put the GCF in front. And we're not finished because we can factor this again. This would be a trinomial, so it's AM method, xx. What multiplies to -7 and adds up to -6? That would be a -7 and a +1. Don't forget to bring down the old GCF. And now I can't factor that anymore, so I'm done. Let's take a look at number 2. Always start with GCF, and if it can't be GCF, move down to the dots in the AM method. I do see that they both have a 2 in common and an x in common. So divide by 2x. 2x to the third divided by 2x. 2 divided by 2 is 1. X to the third divided by x is x squared. 50 divided by 2 is 25, and x divided by x cancels out. Put that in parentheses and put the 2x in front. Now, can I factor x squared minus 25 again? If you said yes, you're correct. This would be, well, it wouldn't be the AM method. That's the difference of two perfect squares. It's the dots method. What times what is x squared? X and x. What times what is 25? 5 and 5. 1 gets minus, 1 gets plus. Bring down the 2x, and you're done. Last one I'm going to do. Look for GCF. I see there's a GCF. They all have a 2 in common. That would leave us with y squared plus 6y minus 27. Put the 2 in front. And then I notice I can factor the trinomial with AM, or I can at least try to. Y squared is yy. Are there numbers that multiply to -27 and add up to +6? That would be -3, +9. Bring down the 2. All right, so that is how you factor completely. I just want to see if there's any examples here that I want to show you one more time. You know what? I want to do number 11 with you. Number 11 gets a little crazy. So what method could we use to factor 11? Well, not GCF. They don't have anything in common. Is that the difference of two squares? Yes. X to the 8th is a perfect square, so is 1. So we'll do the dots method for this one, which is a double parentheses. What times what is x to the 8th? X to the 4th times x to the 4th. For those of you wondering why it's x to the 4th and x to the 4th, remember when you're multiplying, you add your exponents, and 4 plus 4 is 8. What times what is 1? That would be 1 times 1. 1 gets plus, 1 gets minus. So you're looking at this. Got to say to yourself, can I factor this again? Well, x to the 4th power plus 1, you cannot. X to the 4th power minus 1, you can. Because this is the difference of two perfect squares. The D in difference means subtraction. So I'm going to bring down x to the 4th plus 1. And when I factor x to the 4th minus 1, that would be x squared times x squared. 1 times 1. 1 gets plus, 1 gets minus. Are we finished now? No. Which one of these can be factored again? Well, the only one that's the difference of two perfect squares is the last one. And this would be x times x, 1 times 1, plus minus. So that one was a little bit extra, but I want to show you guys how sometimes you're not done even if you factor it a couple times. Okay, so that's factoring completely. You guys can finish the rest of these examples. And now that I've taught you all the ways of factoring that you need to know for right now, I'm going to go ahead and make some sort of assignment, but I'll let you guys know what that is when I make it.